Welcome to Shift GTM podcast. We got two special guests today. We've got Ty and Farouk, who are both the founders of Modaic. We're super stoked to have them talk about Modaic, specifically too about some GTM use cases. And then also Aman has some experience working with these guys using Modaic as well. So we can get into that. But yeah, Ty and Farouk, welcome guys. Do you want to maybe give us a quick intro and maybe talk about Modaic for a second, what you guys are building?
Yeah, definitely. Nice to meet you. Of course, I'm Farouk and this is Ty. And my background was computer science. Went to Boston University, studied CS, was obsessed with AI infrastructure. Ty can explain more about himself.
Yeah, I graduated from MIT last year, was big into AI, did some research at the Media Lab and other MIT labs, and worked on some projects, and then also did some internships, also majored in CS. And Boston was actually, Farouk was at BU, I was at MIT. We ended up meeting in Boston while we were both in college, and then started working on Modaic.
That's so sick. That's a social network story right there.
Yeah.
Meeting in
The way we
Boston.
met was actually pretty funny. We met at General Catalyst Talent Sourcing Salon or whatever, and David Fiacco, the founder of it, had his Icarus Award and was just passing it around the table. And he was working on racing at the time, and I was also, I was just a student doing my own thing. I had a project was working on, but I just got his LinkedIn there. You can kind of smell the talent. So he had a Python framework t-shirt on. It's called Reflex. So, it's, Vol. So I got his LinkedIn and I reached out to him earlier last year, summer, for coffee. And we caught up. We were talking for a bunch of time over our sandwiches. And then fast forward a month, we started working at the MIT Entrepreneurship Building. And he was working on video models at the time. I'm working on the MCP servers. So we sort of collided in the sense that we both had the North Star of wanting to make models better. But I guess the whole, what the labs say works on their evals doesn't translate very well to production use cases in this specificity or agreement gap there is. The models are extremely good at coding. They're very knowledgeable, but they don't have the semblance of judgment or taste, basically. So he thought it was at the model level. I thought that the models were capable enough. It was just the prompts or the orchestration that needed work. So I pointed him to this framework called DSPy, which is automatic prompt optimization, building modular AI programs instead of chucking a frontier reasoning model at every problem and running it in loop and stuff like that. Well, he thought it was extremely cool. I was obsessed with it. He was obsessed with it. So we were like, all right, this is the frontier. Let's build something around this. Something has to stick. So yeah, and that's how we met. That's how we started the thing. And we got our first, pre-seed funding from this MIT fund and then applied to be Ron Andreessen's pre-seed fund. It's Y Combinator adjacent program and got into that. So moved to SF and have been building ever since.
So
Nice.
sick. Yeah.
So I guess where are you guys at now as far as use cases, right? So you have this DSPY thing, maybe a little more tangibly, like what's happening? How are people using you in traditional, I guess, maybe not traditional is the past year. Let's say companies have these LLM flows set up. Where do you guys fit?
So DSPy, just automatic prompt optimization was our North Star, just that people shouldn't be manually handwriting these prompts. English is a very lossy medium to communicate the business intent or a judgment into task execution and machine execution. So DSPy works extremely well when your task is well scoped. For example, LLM to judge or classification where it's just given some unstructured data, make a very discrete decision or determination about this input. And you're proxying how a human would make this decision, basically. So a lot of that work is replacing classical ML, what was decision trees and linear regressions and logistic regressions with LLMs. And now the interface is the prompt or the instructions that you pass into the LLM to go and do the work. So just finding the best way to compile that intent into the best set of instructions that match what you're actually trying to accomplish was what we wanted to do. So I guess Ty was the first one to think about confidence estimation. Knowing when the model is unsure is very, very useful way to find proactively where these edge cases, where there's policy exceptions and where its intent isn't fully specified. So we started iterating around that. We want to build the best confidence estimation primitive. So we set out to build probes and Ty can talk a bit more about probes.
Yeah. So the research with probes mostly came out of a lot of the mechanistic interpretability research. So essentially we look inside the internal states of the models, and we've just been doing much research in a bunch of different ways of using those signals to reveal the things that you can't exactly see in the, I guess you could call it the token space or even the law of prompt space of the model. by actually looking into what is the latent space of the model, what hints can that give us into whether or not it's confident about the decision that it's making.
That's
Yeah.
so sick. I think that was one thing that Farouk, when we met a few months ago and you were talking about that confidence estimation, that was super intriguing to me. I think to put as the use case behind it there, I can see that huge, especially for GTM or, I mean, honestly, any of these scoring use cases that you mentioned, right? Where
Yeah.
you might use a traditional ML approach. Because often an LLM definitely has the reasoning and the ability to do some of these tasks. Adversarial, for instance, a lead classification. It should easily be able to do a lead classification, but then it's really hard because it's a black box. You don't know what's happening under the hood, how confident it is. And one thing that we've done historically, you guys have probably seen this, but people will say, we'll ask the LLM to output its own confidence score.
Yeah.
And then it's just arbitrary, right? Like it's basically fake. It'll be, oh, I'm 80% confident.
Yeah.
What does that mean, right? So I think that's super intriguing. I'd be curious to hear more of how, I mean, you can talk about how you did that or even what that looks, how you're able to kind of give an actual tangible signal of how confident the model is and not just some arbitrary trust me bro metric that the model traditionally gives us.
Yeah. So yeah, there's a lot of papers on it. We originally started with doing essentially like what's called a linear probe. So just a
line of best fit.
Yeah,
basically.
exactly.
Yeah, through the internal representations around the middle layer. In this meta superintelligence paper, they proved that around the middle layer is where the activations for uncertainty are the best representation for how sure this model actually is. So if you train line of best fit through the embedding of a bunch of classification tasks, you can generalize that probe to a bunch of line of distribution classifications or discrete decision tasks, basically. But I guess what we're trying to iterate on and what our metric to hill climb was AUROC, or area under the receiving operating curve. And that metric was, it originated out of World War I, basically just whether or not the radar systems accurately pointed at an enemy plane or whether or not it was a false signal. So it tells you how well your confidence estimation is able to discriminate likely correct predictions from likely incorrect predictions, basically. So the better your AUROC is, the more clustered the likely errors will be around low confidence regions. So that means when you're doing confidence guided review, you ideally want to start with the lowest confidence predictions to label first. You're more likely to find disagreements or errors around that region that you can use to train or have the model learn in the optimization run. But yeah.
Awesome. I think one thing that's really exciting about that is it's a confidence score that's rooted in mathematics and not just another random output from the LLM I was saying.
Yeah.
I think you guys have a really interesting take on analyzing, for example, let's say I have an LLM as a judge system in this email sequence. We're generating emails with AI, and then we're having the LLM score whether it matches against guidelines. A pretty standard use case. We have a system like that in Vercel. I mean, spoiler, we are using Modaic at Vercel as well to accomplish some of this. But essentially, we will have thousands of data points that the LLM is putting out. Can you walk through kind of the different solutions you can use to monitor that? I think evals are part of it. There's random sampling. Do you mind just touching on that?
Yeah, that makes sense. So yeah, the idea is that a judge or classifier is a non-verifiable task. It's a subjective task. A good email and a bad email is subjective per team, per organization. So because it's subjective, there is no deterministic or code filter that you can use to check whether or not your judge is accurate. And because of that, it's like your only options now are review every single judge output and do an exact match between the judge's decision and a human expert or your decision. Or you can do a random sample where I'll check every 100th or 1,000th judge decision and see whether or not I can find any errors. But if 90% are the obvious cases and 10% are the edge cases that are failing, then a random sample only spends 90% of your time confirming what you already know. It's a statistically inefficient way to find and cluster errors. The best and most serious teams right now are trying to find any statistically efficient way to surface disagreements. Some companies are doing discrepancies between user feedback and the judge output. If the user put a thumbs up, but the judge put a thumbs down, then that's a disagreement. And it's likely that the judge would disagree with someone on their team as well. They also do something like model ensemble, where I'll run 3 or 10 judges on the same decision. And if they don't all agree on the same output, that means it's up for interpretation. It's ambiguous. So it's likely that you would disagree with the human as well. But I guess we went through a bunch of different ways to do uncertainty, quantification and confidence estimation, and probe seem to find balance between speed and latency as well as cost efficiency. So model ensemble, like self-consistency, you're running multiple inference forward passes per decisions. If I have 1 million decisions, do I want to run 10 million API calls? And then the other method, verbalized confidence, very poorly calibrated, or log probs, also very poorly calibrated, or reasoning length, anything that is informed by the model's external outputs, because models lie and you can't, like, anything that they say outwardly has no bearing on what they truly are feeling internally, if that makes sense. But yeah. So it's just a bit of a conundrum, I guess the space is in right now. But I guess the people that are doing it are taking a very stats heavy approach to it. And that's seeing, these are LLMs are just really big ML models, basically. So, but the common, I guess, the accepted truth now is that they're non-interpretable. But there's a handful of people who are trying to interpret the uninterpretable and give you a really good signal on whether or not you should trust these proxies for intelligence, basically. But yeah.
Yeah, that's awesome. I think that's huge because I've been seeing this kind of discourse on X recently about how the future of these models is more intellectual, more creative tasks rather than just these automation tasks. I think that we're kind of seeing that as an industry too. Some of the things that we started automating internally with GTM at Purcell was lead classification, stuff that's like pretty repeatable processes. And then now Aman mentioned emails and things that are kind of a little bit more frontier, a little bit harder to reason about. So I think it's really powerful. I mean, I'd love to hear kind of what you guys, how you have productized this, just out of curiosity. I mean, just as you've been talking, it's clear you guys know your stuff. These are really complicated things that like, the normal practitioner is not ready to usually tackle. So I'm curious, like, do you kind of wrap this all up in an API? How does it look for people? How can they implement it? I think that's super powerful what you guys have done so far.
Yeah, so we have an SDK and a platform for all of this. And I guess Modal is doing a lot of the heavy lifting on the AI ML workload and GPU provisioning side of things. They handle idle time and scaling down GPUs and cold starts and all that stuff. But I guess the work is done. The main workhorse is obviously like probes and building those probes. So Ty has put a lot of time into building the best algorithm for them. It is also incorporating different algorithms to do an ensemble of different approaches to get really, really reliable confidence scores. So that all runs in the modal container. And then we call the modal containers with our backend API, just a fast API backend, and we make it really cool, convenient Next.js front end to interact with everything. So we give you the dashboard, how confident is your model currently, what its distribution, as well as its failures or error rates, whether predictions or JSON outputs are failing to be produced. And then we also give you a very convenient like labeling interface. So like every single like prediction that the model outputs on a data point is stored along with like the model in like a Git repository, basically. So like we have like a self-hosted like Git server that versions every single like prompt provision, as well as every single like prediction that the model comes across. So you can view all the predictions, label which ones are correct or not correct, and then each confidence score is attached to the prediction. So that allows you to do confidence guided review. So what I was talking about before, how other options make it very, very hard to scale out the labeling of your judges, evaluating your evaluator. Confidence estimation makes it so that you can sort. You literally just click one button to sort by lowest confidence first, and then you can capture like first 50 to 100 lowest confidence cases, label those, and then we run JEPA, which is the latest prompt optimization algorithm. It automates the experimentation of what your average AI engineer does when they're optimizing the prompts by hand, if that makes sense. Start out with a base rubric or prompt, create samples of or new iterations of that prompt, test it on a validation set, and keep doing that. Keep adding layers to that tree until you exhausted a budget and you have the most optimal prompt. So it's just a very convenient interface. Click the button to align the instructions and run that optimization over the predictions that we've collected before, and then run it. We run it again over each item in the data set so that you can see how much it's improved and how well the confidence got and how well the agreement, how much your model agrees with you now over that data set.
That's awesome. I think that's powerful. I mean, I think, Aman, I'd be curious on your side as you've been implementing it with these emails, but I think from the applied AI engineering path, obviously we're very concerned about all those things and optimizing the prompt and stuff, but to do all of that on our own is a lot of work. And so I feel like it's great to be able to just focus on the outcome purely and then have everything else automated.
Yeah. So like the idea is that when you're doing something, judges or classification, you kind of want that to be a zero. You want all the ops and infrastructure to be figured out and just have to do it. You just want to label. just label the data and then click one button to align it and then be done, basically. Everything else is tedious, annoying. So it's sort of how we're positioning the value proposition. Number one, models can't reliably flag their own edge cases. Number two, manual prompt engineering is tedious, unsystematic, and risks regressions. And
Yeah, I'd say, I mean, as a user of the SDK, it slotted pretty seamlessly into our workflow. And so for context, we have a workflow that runs through each contact to do some research, generate an email, and then go ahead and set up that email instead of outreach for our sales team to go ahead and send. And so with Modaic, I mean, you guys are basically scaffolded everything in the SDK. I'll basically pass in the emails that were generated and then the guideline into Modaic. And then under the hood, also, we're able to use the AI gateway. So that's just that's cherry on top. Then we get the output of whether that like passes or fails against the guidelines. And then we can just rerun it, right? And we have those prompt optimizations we can do later. But within that workflow, I can just basically slam it against the the LLM as a judge until I get a passing email, and then I can move on. And what's really nice, and we're experimenting with this, is in these emails, we're realizing that there's a few handful of frameworks that sales leaders have, different email styles and tools and tips. And so each one of those is becoming a Modaic arbiter. And so we're basically taking this email through this whole pipeline of arbiters that just verifies quality along. So it's kind of, you have your marketer looking at the email first. Okay, thumbs up. Next, you go to the sales leader. They're looking at the email. Okay, thumbs up. And you just kind of go down the line and it's all statistically backed, which I think is really awesome. I compare this flow to evals, right? That's obviously, I think, the first solution that folks had. Can you talk a little bit more about how the Modaic approach with arbiters differs from the eval approach? Because I think they're both trying to basically tighten in.
Yeah, I know you guys. Ideally, is basically you guys are making an agent for outbound emails. Why not just stick that into something Brain Trust or Langsmith and try to eval it? Well, mostly, I guess the biggest value proposition is that we aren't promising way to collect data efficiently or anything like that. That's a software issue, basically. The hard part is scaling out the actual eval, like the labeling of this data. So we're just giving a very efficient way to proxy your judgment, the expertise and the experience of your sales experts, your marketers, in something that you can package and version software and scale out the labeling of that data and know when a perfect employee is intelligent because they know when to ask for help, they know when to escalate. That's what intelligence to us is that if I don't know something, I will learn it or I will ask for help from someone who does know that and correct that. So the last thing you want to do is guess, basically. So traditional solutions give you the primitives to collect the data, the traces and stuff like that, but they kind of leave you up to your own devices when it comes to scoring and labeling out these emails yourself or just anything, traces.
Yeah, I think that's a really good way to frame it. Is that it's a software problem versus maybe a data problem.
Yeah,
or an ML problem. Yeah, because I mean, I know Aman and we're very versed in software engineering. I feel very confident in our ability to build this agent, make sure we have observability, etc. But then it's often when it comes down to the prompt or what do we what is the inputs to the model? How do we optimize it? Sometimes it's tough because we're very concerned with the software side of it. It's hard to concern ourselves with all of the other things that go into building out a resilient agent that can perform well. So it's cool that that's kind of offloaded in a way.
Yeah.
Sweet. Yeah, I think maybe the other point to that also with evals is, at least in my experience, Cam, maybe you can, let me know if you agree or disagree with this. But usually when I use evals, I kind of looked at them as unit tests for my code. But the problem is I have a kind of a defined list of problems, and we still have that problem of this is a subset of what the LLM is going to generate. Because the LLM, for example, we've been generating, say, hundreds of thousands of emails now with our AI tool. And just the other day, one of our team members flagged an email to me where it's starting to leak some internal stuff that we use to rate contacts. That has never happened before. I do not have an eval I would not have an eval for that. But for all intents and purposes, the LLM is just operating just fine. So it's I think what's really compelling about the Arbiter system is that it's kind of looking at every email as it's being generated, which again would be pretty ridiculous to do for each eval to compare it against that. It just doesn't fit the workflow.
Yeah. I think the biggest thing too is it's kind of a moving target with some of these more creative tasks that are pretty, it's not objective if it's a good email or not. It kind of depends on who you ask. And so we have our own standards, sales leaders have their own standards. So I feel like the tough thing about evals sometimes with that is it's a moving target.
Yeah.
The prompt might change a little bit. What someone likes might change a bit, especially based off of the inputs of who the individual is that they're sending it after. So I think it's almost this cat mouse chase where you're you change the eval, have judge to say, is this a good email? But then the prompt changes, or you have to change the eval.
Yeah, for those emails, it's a policy changes as well frequently,
Yeah,
right? It's situational relevancy. Maybe this promotion
totally.
is like a month behind, or we're focused on this campaign now. So each new campaign change is a policy update, prompt change that you have to do, and now try to figure out a way to not regress on your past failures. So having each prediction tracked to that judge and calibrated so that you can just recompile, re-optimize over the best instructions for that policy change or that prompt change is the most efficient way to continuously do that and make sure that you're always staying on track with what good looks for a given email.
Totally. Yeah, that well said. And I think, I mean, Aman and I have done this before where we're not using Git. That's actually really smart to just host a Git server, but versioning prompts to be able to try to find regressions or especially when something like this is so tied to performance, especially in sales, these emails have downstream effects that drive budget for organizations, compensation for people if these emails lead to a closed deal or an open opportunity, et cetera. And so tying that back was really important for us. And so it's cool to see, things are versioned, right? There's a clear ledger of what's been happening. I think
distorted truth almost of what
yeah,
how it's transforming over time throughout your work.
totally. Yeah.
Yeah. Sweet. I guess as we wrap up here, Ty, Farouk, anything else? Any parting thoughts? Anything you guys want to leave the audience with?
I don't know. Just use Modaic. Sorry to we got to plug ourselves in there, but yeah. I mean, we're obsessed with this problem. We're getting at it. At the end of the day, it's if an LLM is going to replace a human moderator or someone who's labeling data or someone who is making very judgment heavy, taste heavy decisions, you want to be able to, number one, measure it. And number two, know that it's aligned to your business goals. So this whole digitization of judgment is a big thing, big prevalent thing that will be going on in the future as well. So it's, we have programming for traditional software to encode our intents. What is this next interface? What is this next programming language for judgment, for taste? How do we encode what we love and what we care about and why we do the things that we do until these LLMs will go out and do it. But yeah, I mean, that's the gist. Ty, anything?
Yeah, I guess I would just say arbiters are pretty interesting because you have ML models that, they are kind of constrained with how much they can reason about different types of problems. They're very specific. They're not very general. But at the end of the day, you can use BERT with a linear classifier and get a confidence score at the end. And you can do so many downstream things with those confidence scores. On the other hand, LLMs are very general reasoning models. They're extremely good at zero shot kind of alignment. Just prompt optimization can get you pretty far. They can reason about completely new situations, new problems, and they're extremely accurate, but they're not very transparent into how confident they are. And so I think it is a really interesting regime to combine the two things together. And there's a lot of really interesting workflows that we've seen ourselves when those two things can be combined together. So yeah.
That's awesome. Yeah. Thanks guys. Thanks for being on. I think my closing parting thoughts here too is I think that if you, especially in something sales that's not necessarily a codified way of doing things, it's different according to each org. You said there's some creativity involved with it. I think that if you spend enough time trying to build agents in these spaces or, or in applied AI relating to sales GTM, I think you will face this problem. And so, I appreciate you guys walking through the Modaic solution and definitely check out Modaic. Thanks for tuning in. We'll see you guys next time.